Before stars, galaxies, and even time as we understand it, the universe was unimaginably different. This story begins nearly 13.8 billion years ago, at the dawn of our observable universe. From an extremely hot, dense early state, the universe began a rapid expansion of space itself. As the universe expanded, its primordial state spread out, becoming increasingly diffuse and less concentrated. As expansion continued, the primordial glow became increasingly diffuse, eventually fading completely from view. The universe grew darker, but gravity never stopped working. Gravity slowly gathered vast clouds of primordial hydrogen and helium, quietly preparing the universe for the birth of its very first stars. Gravity quietly gathered primordial hydrogen and helium, drawing the drifting clouds toward a common center long before the first star was born. Guided by gravity, vast clouds of primordial hydrogen and helium slowly circled a common center, drawing ever closer before the first stars could ignite. Invisible gravity slowly gathered enormous clouds of primordial gas. Invisible gravity slowly gathered enormous clouds of primordial gas. Each collapsing cloud became hotter, denser, and more energetic.
Eventually, the central core reached extraordinary temperatures.
Then, the universe witnessed its very first stars. These giant stars flooded the young universe with powerful light.
The universe's first star now burned intensely, flooding the surrounding darkness with its brilliant primordial light.
Across the young cosmos, the first generation of massive stars illuminated the darkness, marking a new chapter in cosmic evolution. Inside them, the first heavier elements slowly began to form.
Deep inside massive stars, nuclear fusion forged heavier elements such as carbon, oxygen, and iron, preparing the ingredients for future worlds.
When massive stars exploded as supernovas, they scattered carbon, oxygen, iron, and other heavy elements across space, enriching the universe for future stars and planets. Invisible gravity slowly united the earliest stars, giving birth to the universe's first young proto-galaxies. The first young galaxies continued to grow, drawing in gas and stars under gravity, shaping the foundations of today's cosmic universe. For billions of years, young galaxies evolved into magnificent spiral galaxies, shaping the universe we observe today. Gravity slowly united the universe's earliest stars, giving rise to the first young galaxies that illuminated the cosmic darkness. Within the Milky Way, an immense cloud of hydrogen, helium, and ancient stellar material quietly awaited the birth of our solar system. A nearby supernova shockwave disturbed the giant cloud, allowing gravity to slowly begin its long collapse toward the birth of our solar system. Gravity steadily pulled more gas and dust inward, causing the growing central region to gain mass as the vast nebula slowly collapsed. Gravity steadily pulled vast clouds of hydrogen and helium inward, continuously building a denser central mass that would eventually ignite as the gravity compressed the cloud. Conservation of angular momentum caused its rotation to accelerate, making the shrinking nebula spin faster. As rotation continued, the collapsing cloud flattened into a rotating disk, concentrating material toward its center. As gas accumulated at the center, gravitational compression made it increasingly hot and dense, forming a young protostar, not yet a true sun. As gravity compressed the protostar, its core grew hotter and denser, creating the extreme conditions needed for hydrogen fusion. When hydrogen fusion ignited in its core, the protostar became a true star, the sun, releasing light and energy into space. Around the young sun, tiny dust grains collided and stuck together, gradually growing into larger rocky bodies.
As rocky aggregates continued to collide and accrete, they grew into kilometer-scale bodies called planetesimals.
Gravity drew planetesimals together, and repeated accretion built larger planetary embryos, the first protoplanets. About 4.54 billion years ago, repeated impacts and gravitational accretion gradually built Earth into a massive young planet. As proto-Earth gained mass, its gravity grew stronger, attracting more planetesimals and increasing its size through repeated impacts. Giant impacts reshaped young Earth. One such collision with Theia may have profoundly altered its interior. Debris from the giant impact gathered around Earth, gradually accreting into the moon we know today. The young Earth orbited the Sun, while the newly formed moon slowly circled Earth amid the debris of the early solar system. Close to the Sun, rocky planets formed in intense heat. Farther out, colder regions favored the growth of giant planets. For hundreds of millions of years, the solar system gradually cleared, leaving 8 planets in stable orbits around the Sun.